Hello friends, hope you all are doing well. Now, today we are going to do a next question in this series, and the question is trapping rainwater. So, let's read this question. So, it is given that there are there is an n non-negative integers representing an elevation map with the where the width of each bar is 1. Now we have to compute how much water it can trap after raining. So what is given is that there is an integer array height, and it has been storing the you can say elevation of every block in this map. So as you can see, at the first index the elevation is 0, so the block height is 0. Second, the block height is 1, that means the elevation is 1, so there is a height of 1 for the first block. Now so on the graph is made, and what it is asking, that if you rain from the top, how much water it is going to retain. So you can see that the extra water is going to flush out, but there is a gap in between the blue portion which is going to be stored. Now we have to find this, how much amount of water it is going to store. So here you can see that the graph is given. So let's analyze this. So let's first index this. So I'm going to index it 1 2 3 4 5 6 7 8 9 10 11 12. So there are 12 indexes. Now let's understand how it is going to be retained water. What is the scenario for every index? So let's assume we are taking first the sixth index. So what you are saying, that it is retaining water due to two walls, because in a bucket or in any container, what you see, there are walls which are taking the water or storing the water at the place. So here the water is being placed by two walls, because if there is one wall, it is going to flow from the other. So it is being stored due to two walls. One is from the left side, and another is from the right side. So by this it is going to store. Now you can see that how it is going to be defined. So it is going to be defined by the maximum. So you have to find out that what is the maximum height before this index, and what is the maximum height after this index. If you can find the maximum height between after and before, then you can say that whichever is the smaller highest elements. Here you can see that after this the highest is going to be this, which is equals to 3, and before it the highest is 2, which is this. So you can see that the water level is always going to be with the minimum of the maximum of both two. So if the maximum here you get at the eighth index, which is equals to 3, and here you are going to take get at the fourth index, which height is going to be 2. So what is the maximum height which can be stored at the sixth index is going to be the minimum of both maximums, because after you if you try to fill above it, it is going to overflow from this side. So the maximum is going to be minimum of both side maximum. So this is going to scenario for every index. If you take any index, let's assume this third index. So if you, what we have to find out, we have to find out the walls after and before. So if you try to find out walls after it, so what you see, that the maximum height after it is 3. Okay, and the what is the maximum height before it, it is 1 for 3. Okay, so here it is 1, here it is 3. So the at the level of 1, the water it is filled up to level 1. Now if you try to fill water above it, what is going to be, it is going to be flown away. So this is the scenario for every index. This is the main condition which we have to understand, that what we have to do, we have to find the maximum height from the left and right side, and we have to take the minimum one, because if you fill above it, it is going to overflow. So if we can find that, then what we have to do, we have to just find out the height left uh, above it. So if you are at seventh index, assume we are at 7 index, so what is the amount is going to be. So here you can see that the left side highest is 2 and the right side highest is 3. So we are taking 2. Now its own height is 1. So if you minus that, you are simply getting 1. So 1 is the unit of water which is being stored. This is for the all index. So let's see for the sixth index earlier which we have discussed. So we are going to take the minimum. So here it is 3 and 2. So the minimum is 2, and the height of 6 own is 0 because it has no block. So it is going to store 2 amount of water fully. So this is how this question is going to be solved. Okay, now let's understand the approach, how we are going to solve this question. So we have already understood what we have to apply in here. So let's understand the approach which we are going to follow. So our approach is going to be simple, straightforward. So as mentioned earlier, what we have decided to find out the maximum for each index. We are going to find out maximum if it is index 2. So we are going to find out the maximum before it and after it. So and we have to take the minimum. So for this purpose, the one situation which can come into your mind which we are going to apply is that we are going to take two vectors and we are going to store the maximum for every index before it. Okay, so if you're at index 2, what is the maximum for it before it? So it is going to be 0. If you move to third index, the maximum is going to increase to 1. Now if you move to fourth index, the maximum is already 1, so it is going to be 1. So that's how we are going to store. We are going to first store the maximum before every index, and we are going to store it in, let's assume, at b vector. And after that, what we do, we are going to store the maximum after every index. So for this purpose, we will start from the last index, which is 12th index, and we check. So the first you get the maximum equals to 0, because the starting index maximum before it is always 0. Now when you move to the 11th index, what you will do, you will increase the maximum to 1 due to the previous one. Now when you move to the 10th index, you increase maximum to 2. So that's how we are going to store our maximum for previous in our P. So in B, it is going to store the maximum for every index before it, and for in P, we are going to store the maximum for every index after it. Now, what we have to do, simply at final stage, we will take the first element from this at index 0, and the first element at this at index 0, and it is going to give the maximum value for this index before and after. And simply what we have to do, we have to take the minimum. So this is the approach which we are going to follow. So that's all. Let's try to code it. So let's start coding. So first let's take size of this height. So height dot size. Now as discussed, we are going to take vector, which is going to store the maximum before and after every index. So let's take the vector name as v before, and let's initialize it with 0. Let's take another vector b after. Let's initialize it also 0. Now let's run the for loop. For int I equals to 0, I less than l, I plus plus. Now what we have to do, we have to first find out the values for the before and after. So for this purpose, what we have to do, we have to initialize two more variables. So let's take it before and after. So we are going to take b as 0 and a as 0. Now here what we do, we are going to do for before. So for before, what we are going to do, we are going to check if it is equals to max of b and the value before it. So for this, what we have to do, because we are starting from the first index, and if you start from the first index, the maximum is going to be before it as always going to be 0, and for the last index also maximum after it is always 0. So let's start from first index, and let's take the max for b, and another is going to be height I minus 1. So what we have done, so what we've done here is that when you move to the first index, we have taken the maximum, which is for the previous one, which is 0, and the value at this index, which is the first index, which is also 0. So it is going to be the maximum for the first index before it. Now again, we are going to do for the last one, we are going to do in the same loop. So we are going to do a equals to max of a comma height, let's say l minus I. So it is going to give us the last index simply. So we leave it as it is. So what it has done at the last point, it has taken the maximum for a, which is going to be the maximum for the last index, and the value for the last index, which is 1. So here a is 0 and height l minus I is going to be 1. So here you're going to take get a equals to 1. So that's how we have taken the maximum for both second last and first index in this factor. Now let's move to our next, which is going to be storing these values. So we are going to store before vb is equals to vb at which index we are going to store it at I index. So it is simply I equals to b. Now let's store for the from the after index, which is vb, and it is going to be index for l minus I minus 1, because here we are taking the second last one, because we have started from the first index, so we are also starting from the second last index. So it is going to be a. So that's how we have filled our vector. Now let's run the next for loop to store get the value. So for this we are going to run for int I equals to 0, I less than l, I plus plus. Now what we have to do? So we have in our hand two vectors which has stored the values for every index, maximum before it and maximum after it. Now after this part, as we have discussed the algorithm, we are going to apply it. So let's take a simple variable. Let's take int and z is equals to, and in here we are going to first store the minimum of both maximums, which is left and right. So the maximum left and right are stored in vb and va. So it is going to give the minimum, and when we get the minimum value, what we have decided that subtract the value present at that index. So we are going to subtract height I. Okay, so this value can be negative in some situations, so we are going to take if z is greater than 0. So what we have to do, we have to increase. So let's also, we have to take one variable answer, so equals to 0 initially. Now if z equals to 0, we are going to do ans plus equals to z. So this is going to store the values in our answer. Now at finally we return answer. Now let's take the return. So it is successfully accepted. Now let's submit this. Okay, so all test cases passed and it is successfully submitted. So this is a good question, and this question is almost similar to previous one, where we have to apply a logical thinking for every index. We have to think what is going to be the situation. So that's all for today. Thank you all.